Question 16 is of matrix match type. Let's read the question. It says situation in column 1 gives two conducting systems M and N. M is rigidly fixed and N can move freely. Ignore gravity and match the response of N in column 2 for the situation stated in column 1. So the first entry is, entry A in column 1 is this, that two rings made. The statement says M and N are coaxial, similar small circular ring with their centers separated by distance x. They carry constant current in opposite sense. Okay, so they are carrying current in opposite sense. Which of these entries will match? Let's look at them one by one. He says force on N is attractive. He says they are current in opposite senses, so the force will be repulsive. So P will not match with A, but Q will match. So let's start writing. For A, Q matches. Then entry R says torque on N is 0. Yes, by symmetry torque will be 0, so this is also correct. Force on N is 0. Well, we have already seen the force is repulsive, so S cannot be correct. T says N is rotationally unstable. Now if the currents are in opposite direction, that means if magnetic moment due to M is in this direction, right? That means field due to M also is in this direction, and the magnetic moment of N is in the opposite direction, which means it will be in unstable equilibrium. N is rotationally unstable will be correct. Let's look at configuration given in B. B says M and N are coaxial, similar small circular ring with their center separated by distance x. Only M carries a constant current I0 initially. Suddenly the current in M starts decreasing. Okay, so when current in M starts decreasing, then there will be induced current in the other loop, in loop N, and the current will be such that it opposes the cause, which means the direction of current in M and N will be same, because the current in M is decreasing, and that's why current in N also is in the same sense, which means the force will be attractive. So for B, we can see that the force is attractive, so P matches. Obviously Q will be wrong. Q will not match. Torque on N is 0. This will be correct. There is no torque. Force is not 0, and rotationally it is unstable. This will not be correct, because rotationally now it will be stable, because if we look at the direction of magnetic moment of this coil and the field due to coil M, we can see that they will be in the same direction, which means they are rotationally stable. So T does not match. Let's look at option C now. For situation given in entry C, this is the current. Due to this current, the magnetic field line, let's say I draw one magnetic field line, goes like this, and this is the conductor N. So at this point, B is like this. Ideal will be in this direction. So ideal cross B is outward direction, right? Ideal cross B is in outward direction. If I look at this point, ideal cross B is in the inward direction. Okay, so that means the two forces are equal and opposite. By symmetry, the net force will be 0, but there will be a torque, right? So let's look at the different options now. Force on N is attractive. This is not correct. Repulsive, that is also not correct because the force is 0. Torque is not 0. Force is 0, so S is correct. And it's rotationally unstable because we can see that there is clearly a net torque there. Let's look at entry D now. In entry D, we have two coaxial and concentric small circular loops. M is the loop with larger radius. Initial currents were 0 in both the loop. Now the current starts increasing in M. Then what happens? If the current in M starts increasing, then there will be induced current in N, and the sense of this current will be opposite to the sense of current in capital M. Now because of the configuration, the force will be 0, which means S will be correct. Torque is also 0. So R is also correct. Now since their magnetic moments are in opposite direction, so it will be like unstable equilibrium, and so T is also correct. So this is how it will go. A matches with QRT, B matches with PR, C matches with ST, D matches with RST. Let's go to question 17 now. Question 17 says, in column 1, surface, refractivity and object are indicated, and in column 2, possibilities about images are given. Match them appropriately for mu1 greater than mu2. So let's look at entry A in column 1. This is the situation given to us. It's the important point is that mu1 is greater than mu2. So if you simply trace the diagram, suppose we assume, let's say this is the center of curvature, this is the normal then. Now the ray, since mu2 is less than mu1, will go away from the normal, which means it will, its original path was like this, it will go something like this. Now if that is the case, then image forms somewhere here. So the image will be virtual. A matches with Q. Image may be virtual. Image may be diminished, of course. Image may not be of same size because of the path taken by the ray. It's clear that image will be diminished. Let's look at entry B now. Now here the word object is virtual. Let's say this is the center of curvature and this is a normal. So the rays will go, they are going from mu1 to mu2. That means from optically denser to optically rarer medium. They will go away from the normal. So they will go something like this, away from the normal. Now the image here will be real but diminished because the actual intersection will happen. So image may be real, P is correct. It may be diminished, is also correct. It cannot be of same size. So other options are ruled out. P and S match. Let's look at situation C now. In this particular case, I simply draw the normal again. Original direction is this. The rays are going from optically rarer to denser medium, so they will bend towards the normal. Now they can bend at different angles, right? They may bend just a little bit. If they just bend just a little bit, then image is magnified and virtual. If they bend sufficiently, then image may be real, it may be diminished or magnified. It can also be of the same size as that of the object, which means in case C, P matches, Q matches, R matches, S matches, and T also matches. Let's look at entry D now. Again, we take the center of curvature and draw the normal. The ray will bend towards the normal. That means it will go something like this. This is one possibility. If it bends sufficiently, then we may get a virtual image. If it bends little, we get a real image. And since both real and virtual images may form, the image may be enlarged as well as diminished. All possibilities exist. That means for D we can say P, Q, R, S and T. They all match. That completes the matrix matching for question 17. Let's go to question 18 now.